and I'm Ben Carter here in the UK. So, yeah, the context for today's presentation is that Comsof works with local authorities in Europe and in the UK, and many of whom have a goal, a stated goal of reaching carbon neutrality by 2030, or certainly an aspiration to head towards that. So that means there's a lot of discussion going on how we can reach that goal, and heat is a big part of it. We'll go into that in a moment. We're going to talk about the challenges related to heat network scenarios for energy master planning. So all of you involved with energy master planning, even if it's not specific heat that you're looking at right now, I suspect that heat will have an important part to play. We're going to look at the Comsof approach and how that informs energy master planning and heat network development. I'm going to present a couple of case studies that we've done here in the UK, and then we're going to hand over to our friends at Rotterdam to look at how they've taken Comsof from moving it from the conceptual piece to how they've used it to help really plan their delivery of a heat network, which is very exciting. And then we'll invite Chris back in for a couple of comments, and then we'll move into the Q&A. So we've got a lot to pack in over the course of the next hour or so. So in the UK, heat accounts for over a third of all emissions. Space heating and cooling is 17% of that. And once again, that really does put into context how important it is that local authorities and the economy as a whole decarbonizes. And if we think about 2030, you know, if this was a 10-round boxing match this decade of ours, the first round's done, and unfortunately we were all a bit on pause. We now need to move ahead with some level of swiftness to start really making a difference, and that can be done in many ways. I'll hand over to Kurt now to share a little bit about Comsof.
So good morning, everybody. Thank you for joining this webinar. I will start with a brief introduction on Comsof. So Comsof is based in Ghent, in Belgium. We have been around for more than 20 years, and our background is in the telecommunications. So we have another tool for optical fiber network planning based on this platform that we have developed, Comsof Heat, for district heating planning. As you can see, we're active in more than 70 countries, but this is of course mostly for the fiber planning designs for district heating. It is currently limited to 4 or 5 countries in Europe, so UK, Netherlands, Belgium, Germany, and a few others. Next, please. So if we look to the heat network project development stages, and this is a diagram from BASE, in fact, we see that the first 2 stages, heat mapping and master planning and feasibility study, so that's in fact where Comsof is very valuable. And if you click, you will see the animation. So Comsof is there in the beginning, the first 2 stages, and it can also serve as an input for the detailed design in step number 3. So next slide, please. So if we look what needs to happen in these stages, so basically you want to compare multiple scenarios, simulate different uptake scenarios, look at possible rollout plans. You want to have good visualization, you want to design your network. So this is all possible with Comsof Heat, as you will see in the case studies that Ben will present. Now, if we look, what are the alternatives? How do engineering and consulting companies, which I've talked to, of course, not all of them do it in this way, but how do they work? Typically, so they have kind of in-house development of a tool for sizing, for planning, for cost calculation of a new network based on Excel, maybe with some Python development, some minor GIS integration. And if you click on the next step, and of course, you need one kind of a superhero in the company who can develop, maintain, and work with these tools. The problem there, of course, it's not scalable, it's time consuming. developing software is not their core business and it's error prone. So you need something which is not all of that. Next, please. So we have tried to bring it all together in one tool, make a scalable tool. Scalable means it can serve for small projects, let's say 30, 40, 50 buildings, up to 100,000 of homes, as you will see, which is a case in Rotterdam, but also scalable in terms of, let's say, training extra people to get on the software, to work with the tools. So you can easily train multiple engineers in your organization to start using the tool. So as an input, what do we need? We need GIS data, we need energy demand data, technical parameters for your design, unit costs if you want to calculate a deployment cost, and that's a starting point. Then what will our tool do? It will generate the network topology, size the network, calculate the deployment cost, and if you want, you can also look at investment analysis of a project over a period of 30, 40, 50 years. So that's also a possibility. So in fact, it gives you a techno-economic assessment of a district heating network. Next, please. So now, if you look, what is in fact automated? So if you look on the right side, the clustering is automated. So you can cluster groups of buildings together to get a certain power for an energy center in a certain area. You can cluster number of homes together. The routing is automated and cost optimized, plus the sizing of the pipes is fully automated. So it's quite fast in generating a new design. So a design, as you see here on the right side, is about 1,000 or a bit more connections. That is generally done in less than 5 minutes. Next, please. It gives you insight in the financials. So next to the bill of material, as mentioned, you can get investment analysis overview. Here you see an example for Glasgow, where we have compared 8 different cases with different costs for the energy supply for big river source heat pumps. And we compared different tariffs for the end consumers, going from 6 pence to 12 pence. So, and we can easily compare and look to the most interesting cases. As I mentioned, you can easily compare multiple scenarios, and here is a nice example of a project where more than 50 different scenarios have been calculated, all quite fast. As you see, 2 to 5 minutes per scenario calculation to really look at a sensitivity analysis of multiple parameters and come up with a kind of an optimal design to take it forward. If you want to read more about it, there is a white paper on our website available if you go to comsofheat.com in our blog space. Comsof Heat comes as a plugin for GIS tools. We currently have 2 plugins available, but we are open for integration with other tools. We have an integration with QGIS and with RGS Pro. QGIS is freeware and easy to get started with. RGS Pro is commercial software and offers, of course, more functionalities, but both are available. Next, please. All right, and then I hand it over back to you, Ben.
Thanks, Kurt. Okay, good. Little poll for you all, just to sort of take the temperature as to where you all are on your journey. So just a quick little poll. If you could all, it should appear in front of you, and you should be able to answer the question. There you go. Are you involved? There's 3 polls. If you could just answer yes or no to each one of these, that would be great. Are you involved in local area energy planning, local heat and energy efficiency strategies? So if you're involved in any of those things, yeah, it'd be great to hear about that and get an idea where you're on that journey. We'll give that a few seconds. How are we doing, Kurt? Are people, are we filling up with answers here?
I think we can release the answers. 80% of people have voted, so I will close the poll in a few seconds.
Yeah.
Here we go.
Okay, okay, cool. So yeah, a good portion of you involved in that, right? Well, hopefully this is gonna, what we discussed today is gonna help inform that. Okay, next question, please, Kurt. Yeah, I mean, here in the UK, has your local authority declared a climate emergency? It's interesting, isn't it? Back in 2019, a lot of local authorities here in the UK declared a climate emergency. 2019 seemed to be the year where things seem to galvanize, things seem to accelerate from a point of view of urgency and commitment and ambition. And it was great to see that. And in our conversations with local authorities, we see that that intention is still very, very strongly held. But it's now, where are we? Okay. Ready to move on to the next one, Kurt?
Yes, so let's close this one. We have 65% who has voted, so here we go.
Okay, interesting. So I know that we've got a mixed group here this morning, afternoon. It'll be interesting to see where that splits in Europe and the UK, whether those yeses are mainly UK or not. So there's a job for all that 39%. If your local authority hasn't declared a climate emergency, perhaps it's time to give them a call and ask them to do so. Next poll, please, Kurt. Yeah, does your town or city have the ambition or potential for a large-scale heat network? What we're going to see from Rotterdam is, I think we're going to see a really good example of what ambition and large scale really means. But I'm going to kick off in the first instance with where we are, I think, in the UK in terms of trying to build up a sense of what is possible and build up that ambition. Okay.
Okay, I think we're good to go.
Good to go.
Was it?
Yep. Okay, happy days. You're in the right place. Brilliant. We'll see what large-scale potential and ambition looks like. Thank you very much, Kurt. Okay, so a lot of the work that we've done here, or that I'm going to discuss and show to you, is a result of a project called the Heat Vision 2030 project, which is a collaboration of heat network centric organizations, Comsof, real-time flow control, enterprise IoT platforms, large-scale heat pumps, utilities, how to engage urban and blue and green spaces with Green Space Scotland. So it's a collaboration that we invite everyone and all of you to join in, to get in touch with me about if you're interested in learning more about the work that we do. But it's about collaboration, it's about informing. And what we're trying to do is help inform ourselves, but also the market. And as a part of that, it took us happily into the pathway of Chelmsford. Now, Chelmsford has laid down a challenge for itself to hit carbon neutrality by 2030. It's one of those local authorities that declared a climate emergency. And you know, so across England, you have things like local area energy plans. In Scotland, we have something called the Local Heat and Energy Efficiency Strategy, prerogative for local authorities to start truly engaging, planning that process. But all journeys start at the beginning. And the problem is, of course, is where is the beginning, where to start. And that's what we wanted to explore with Chelmsford. We had a discussion. Chris was with us at the beginning of this process, along with other members of Heat Vision 2030 and the team from Chelmsford City Council. And it was really an opportunity to ask them, you know, what can you do? What do you want to know? Or to let them ask us, what does a heat network look like? You know, and it was really a question of asking that open question. What does a heat network look like for Chelmsford? Well, the basics are go for the dense urban areas where you know there's going to be a lot of heat demand, but also you know you're not going to have large, long heat network pipes. Those are two fairly straightforward and simple key criterion that you want to bear in mind. So in this case, we used the Comsof software. We grabbed the OpenStreetMap data, we grabbed the Hot Maps EU data, and we created a geographical area. We mapped out the buildings, and then we overlaid the heat networks, the heat for each of those buildings on top of it. And we also, informed by Chelmsford, we also looked at 4 potential areas for a heat source. We didn't try and define the heat source at this stage. We just thought, what space is available within Chelmsford to place those heat sources? So it's very much, you know, just having you know, some interesting, broad, open conversations about what could be possible. Okay, and then we added in the technical parameters, which is part of the process. Now, these technical parameters can be very, very definitive, or they can be broad. In this case, we looked at the temperatures, steel pipe system, the pressure involved, diversity or minimum simultaneity, or the coincidence factor. So that's essentially diversifying your overall heat load, so you can say, well, we're not going to have all of the heat demanded all at the same time. So that helps us bring down the total peak amount. And also, one of the objectives of this section of the process with Chelmsford was to benchmark different scenarios. So we were starting to build up different scenarios, and these scenarios were based on essentially, giving us an idea what the relative cost could be depending on the size, depending on the heat load, the heat demand. Now, I won't go into every single box here, but you can see that we've got sort of 4 broad scenarios: the public and commercial buildings, which is what we'll look at now. And it's scenario A and scenario E, because what we did is we looked at the implication in terms of heat network, relative heat network, pipe cost and scope, if we had the heat source in area A or in area D. So, but it was also specifically just for public and commercial buildings. Why those buildings? Because it seemed to us, you know, it's a fairly straightforward assumption that these perhaps would be the buildings that would be most easily able to be convinced or most easily driven towards taking on and connecting to a heat network. And then we looked at B and C. So we said, okay, let's look at it slightly differently. What if we just connect all the large loads that we were able to draw out from our Hot Maps EU data and compare that with just businesses? You know, maybe there's a specific strategy where you're just capturing the businesses. And then this helped us produce these maps. And so you can see on the left-hand side, you know, you've got bigger pipe work because you are having to drive more heat through that pipe work. And on the right-hand side, businesses only, you see you've actually got quite an extensive heat network in terms of the length of the pipe work, the extremes that you have to go to hit all them. But it's actually quite a small heat network in itself. And then we were most interested to see what happens if we went big and we included all of the private sector estates, so included all the households as well. And here you can see that across the piece, you know, we're increasing the number of demand points, the number of buildings substantially. We're increasing the network length, but also, while we're increasing the number of buildings, you know, by almost 10 times, more or less, the network length, the total peak required, the total consumption doesn't go anywhere near that same factor of increase. And indeed, the project cost, that benchmarking piece, the percentage cost per connection, is substantially less as we go big. So returns to scale are evident there. And this is what it looked like. And we were able to, in this case, what you have to do is you have to develop essentially two network designs. You have the transport section, which is the main heat coming from the heat source through to the different parts of the heat network. And the second layer is what we call the distribution section. And that is denoted by having clusters of smaller heat networks that are connected to the main transport pipe work. And then we went through that process again. And I think this is really the gem of Comsof, because it allows you to get to a stage where you're having a discussion with other people from different competencies, technical people, not so technical people, money people, planning people, legislative people, whoever it is, and you're able to have meaningful, interesting, and insightful conversations quickly, and you can refine it and then feed those inputs, those ideas, those suggestions back into the model. So we said, listen, let's go big. Let's see if we can push this go big, this maximum coverage narrative a little bit further. So we said, what about adding in some low carbon heat? So we've added in some a river source heat pump that can deliver 10 megawatts worth of heat. And we've also, we were informed by the people at Chelmsford that there is a planned new build development, household residential development, that we decided that we were going to include as well. So we said, well, why not go a little bit farther and extend our ambition a little bit? So this is what that looked like. You can see in the area here, this was the original city center. We've got the large loads over here. We added in option C, which is the river source heat pump, and we've also kept this heat network here, heat source here. And then the new developments that we've not included in the previous scenario. Once again, added in our technical parameters, what sort of supply temperatures, pipe system, the pressures, the diversity. And now the other thing that we wanted to assess was the cost implications of adding in the heat source from the river source heat pump, and also comparing variable pipe pricing based on the size of the price of the pipe per meter, versus just saying we're going to have a fixed price per meter of heat network installed. And so this is the distribution layer, and you can see the red boxes, which is what we call substations, which essentially acts as a kind of boost to the primary heat network, adding perhaps temperature, perhaps adding a little bit of pressure, but essentially serving these neighborhoods. You can see that in a bit more detail there, the substation then feeding into the roads. So what we came up with was two heat networks. One served, this purple area, served by the river source heat pump, and then this northern area served by the other unspecified heat source as well. And then we were also able to bring out which areas, which neighborhoods are served by each of these substations. So you're beginning to really visualize what's happening, how it would be built out. And you can also add in a functionality of planning, which we'll see in the next example in Glasgow, of how you can plan out the deployment phases as well. So there, once again, we're highlighting in colors the substation, demonstrating which neighborhood is being served by the substation. And we're able to benchmark and compare the two scenarios, and we can see that, let's just assume we have £2,000 a meter per meter of pipe work in scenario one, versus this variable pipe sizing, whether you're larger or smaller pipe size diameter. And once again, if those numbers were specific, correct, we will be able to see a tangible impact on the overall cost, once again informing and providing confidence and information to decision makers within the area. Okay, I'm going to run through this one pretty quickly because I want to make sure the guys from Rotterdam have got their time as well. But once again, we looked at Glasgow, and we wanted to say, okay, well, what about a larger scale city centre heat network? Once again, they've declared this climate emergency. They've got this challenge, carbon neutrality by 2030. How viable is that? So once again, we went through the same process of building up the map using OpenStreetMaps and hotmaps.eu to give us our sort of starting point. We grabbed all this heat map data here, and then we started to refine it down to, once again, what we felt was a suitable first instance area. And this is essentially the two scenarios we're going to look at. There's multiple iterations again within these scenarios, but the two scenarios we're going to look at is what happens if you have one big, large water source heat pump, and then versus having multiple ones. Well, with one water source heat pump, you've got to have a lot of booster stations, a lot of substations to help you along. And that could add a lot of heat, power load. You may have to have a lot of extra electrical power load to sort of keep those substations going. It also may add in a lot more cost. But once again, we looked through this, we were able to build out a phased deployment scenario, demonstrate how the heat network would build out over time to try and meet this goal of carbon neutrality by 2030. And we were able to then demonstrate the cost, the amount of pipework, the different sizes of pipework, and we could also study the cost of this over time as well. We reviewed it and said, okay, let's refine it. And so we decided to say, well, actually, let's split this city into 4 sections and have 4 water source heat pumps, each serving an area of the city with water source heat pumps that are broadly the same size, and see if that could have an impact on the viability, on the cost, etc. And here's it by sections. So no need for substations anymore. All the power, the pump, etc., will be getting delivered by each of those heat pumps. We were able to have the financial analysis. We were able to break down the cost, the capex cost related to the different heat networks themselves. And once again, being able to build out that idea of how it could be deployed in a phased fashion. Okay, I've run through those. I'm now going to pass over to Roland to kick off from here. Can you hear me, Roland?
Yes. Thanks.
Okay, I will turn off my microphone and I will be clicking on your behalf.
Okay, great. Yeah, good afternoon, everybody. My name is Roland Verrooyen from the city of Rotterdam. I'm working there as an energy advisor at the engineering department. And I'm here with my colleague, Frère, to present our feasibility study for a heating network for Rotterdam that should be realized, that are plans up till 2050. So we have a bit more time than the last example. Next slide, please. Rotterdam had a big decision to take after the bombing in World War II, because Rotterdam was almost vanished from the map, as you can see here. And I always show this picture because it's a nice thing, because the positive thing about this was that Rotterdam had the choice to either rebuild the medieval city center with a small street maps and narrow streets, or whether to build a modern car-oriented city. And Rotterdam chose the last option. That was the perfect ground to start a city district heating network. So our our city heating network started in the 50s already. So next picture. You can see here our current district heating system. We have the largest district heating network in the Netherlands. It's roughly 80,000 housing equivalents connected. And on the north part of the river, you see in the orange the Eneco network, and that's also based off the historic network. So the biggest part of this network is started in the 50s and built until the 80s. Then the natural gas came into sight, or even earlier, and the growth of the district heating network then stopped actually. It was taken up again in the early 2000. In 2005 it was taken up again and expanded also to the south shore of the river, where you can see in green the Vattenfall heating network. Our main infrastructure that is shown in red is by a public heating company, Warmtebedrijf Rotterdam, and which transports the heat from a waste incineration plant in the harbor area towards the city center. Yeah, so next slide, please. Yeah, this is an example how it in Rotterdam is going, but maybe also in other cities in the Netherlands, because it's quite a complex system of stakeholders actually involved in the district heating. So we as a municipality made an area concession for heating on the north and the south shore. So we have a close contact with the energy operators, and these operators have then contractors, of course, to build actually the network themselves. They of course have to speak to the municipality about their plans. And then we have the building projects, which have also to have permits from the municipality and work with the plans of the municipality. Then the energy operator themselves, they have to supply the heat to the end user. So they have to make the contracts with the end users, and of course also with the building contractors. Then we have a producer of our residual heat in Rotterdam. It's mainly a waste incineration plant. That's a private company, and also a Shell refinery that's connected a few years ago. And we have then the existing heating company in Rotterdam. As a city, we have different stakes. So we have also the stake of the legal affairs. So we also submit the permits for putting the pipes in the streets. So we have close contact with mainly all the stakeholders. So yeah, it's quite a complicated stakeholder system, I would say. And what's also interesting, I think, here are a few cases of how the private and public ownership can be divided into the four different tasks of a heating network. So the first example is an example that's also from the Netherlands, where the producer is public, and actually every part of the system is public. So also the network operator and the supplier. That's in the city of Purmerend, the case. Then we have a mixed one with only the producer of heat being private and the rest being public, and that's the case in Roosendaal, and then the producer is Suez. And we have an example of where the production is public, and the rest is private, and this is an natuurlijke network. And the other one is a mixed one, where the producer is private and also the supply side, the distribution grid is private, and that's the case in Rotterdam. So actually, as a city, we have the public part in hands with the heating company Rotterdam that connects the source, like the producer, towards the supplying energy companies at the end. So and what you can see here, what's the case number one, where everything is public, then the city or the local government has maximum influence on how to expand on or which buildings to connect, and the other one where everything is public or private, then the influence gets less and less. So in Rotterdam we have a mix of this. So next slide, please. It's important that in our heating plans we focus on the heat transition, but actually as a city we're also busy with energy transition, because energy transition of course is broader, and a lot of heat demand is being electrified. And actually in the case of our Comsof work, we focused on the areas that were to be connected to a thermal collective energy system like district heating. But we expect in the near future that storage of, for instance, solar energy and wind will be a really important one, and also the electrification of the mobility. That's in the Netherlands also becoming really a high thing. So the network will change, and it will be the meaning of this picture is only that it's becoming more and more complicated. Like end users will also be producers of energy, so that makes the network a lot more harder to predict and more complex. Next picture, please. Yeah, just really in short, the heat transition in the Netherlands. We had a political choice being made in, I think it was in 2014 or 2015, where there were a lot of earthquakes in the northern part of the Netherlands. And then it was decided to get rid of natural gas, actually. I think we are the only country in Northwest Europe that has this ambition. So we want to be totally natural gas free in 2050, where we have the largest natural gas network in the world. Almost, I think 95% of each house, or of all the houses, are connected to a natural gas grid. So there's a lot of assets in the underground at the moment. So that is a big shift for us. And at the same time, we of course we met the Paris Agreement for CO2 reductions to reduce like almost 50% in 2030 and 95% in 2050. And this year is actually a really important year for all the local municipalities, or the local governments, because each municipality has to submit their heating plans to the national government, how they will supply each area or the areas in their municipality with heat the next periods. So more mandate is coming to the local government, and there has been from the last few years a lot of subsidies going on for pilots to address pilot areas. It's like almost 40 areas in the whole Netherlands that has got a subsidy for becoming natural gas-free neighborhood, but still there's no structural finance. So there's a lot of costs involved. So this is still a bit of a problem to get the whole city natural gas-free. And as I stated earlier, the energy transition is broader. So in Rotterdam, for the heat transition, our main coordinator is the sustainability department in Rotterdam, and our role from the engineering department is to make to have more the technical details in-house. So we are a public engineering department. We belong to the city council, and we carried out at the end of last year a feasibility study with 14 areas. Yeah, the outcome was, and we coordinate also external advising companies that contributed to this, and we used our knowledge from due diligence in every area. So in each of the 14 areas, we had a different person that was really the eyes and ears in these areas. At the same moment, we have 5 areas that are already being in progress of planning really the becoming natural gas-free area. Some of these also got the national government subsidy, and 14 areas are now in the study phase. And the first area is going in realization at the moment. And lots of studies already have been done also by external advising companies, because it's a huge task actually for us as a city. Next slide, please. In 2018, we made a map of which heating solution would be fit in what part of Rotterdam best, and from a financially point of view. And you see here the red areas are the areas also around city center, and the more dense city area, where you can see that collective high temperature heating grids are really the main solution from this study. And the bluish colors are where the all electric or scenarios or the better are more feasible. Next slide, please. Yeah, and actually we as a engineering department made this conceptual model for the feasibility study. And important is of course the data and data quality control. So we have a lot of data from ourselves as a city. The design, and there Comsof came to site, and the decision model. So you can click through this slides. Yeah. So you can see to the left the map of the 14 areas that were to be developed, where we got all the data. on what is the energy consumption from the grid operators, what's the energy consumption at the moment, what will be the energy consumption in 2030 and 2050. And at the right side, you see the design we made with Comsof. Yeah, with different scenarios. We made 3 scenarios in our feasibility study. 2 of them, or one is 100% of each building has to be connected, including the utility buildings. The second one was 70% connected. So these were the scenarios where each of the 14 areas could be, could serve as a reference for all the areas. And then we made for each area, with the due diligence input, a customized scenario, what would be the best solution for 2030 for each area. And actually, our report, we made this for the sustainability department, and this is also the department that will talk to the mayor of the city and to make a decision on which area will go into in the operational or in the engineering phase. So next slide, please. So yeah, we made, as I said, the due diligence on best heating solution for 14 areas, and our study actually is input for to update the map I showed from 2018, and Comsof we used as a main tool actually for this. So the financial parts and also the heating network design is actually 100% made with Comsof. We found out that it's like 80-20 or maybe even 90-10 division between data gathering and data quality control, and then actually making the design. So to get the data right was the hardest thing, actually, to have this at the same level of detail for all the 14 areas. The 14 areas that are roughly 100,000 houses, but it's in housing equivalents even 160,000. And the came out of the study was that most of the areas will be connected to a centralized city district heating system, and some that were more remote in the city will have a standalone local heating source, or have some all-electric areas. Yes, next slide, please. The unique selling points of both our engineering department is actually that we are in control of the data. So it's actually the city data. We have also short connections to the other departments in the city, the technical department. And we have a long-term development scope. And at the same time, the Comsof unique selling points are that, it's in our opinion, a market leader with a geographical and heating network tool, where also a nice integration with free GIS software. And the support we found out was really, really fast and to the point. So that was a really good one. And it gave us really good insights in financial and investment costs of the heating network. So next slide, please. So here you can see the 14 areas that we made the feasibility study on. That's maybe next slide, because we're running a bit out of time.
I am here.
Oh, Freya, yeah. So yeah, Freya,
yes, I'm here. Yes.
Through this, yeah, great.
Yes,
thanks.
I was able to go on the phone.
Great.
Well, please the slide before, if you are. Yes. Well, here you can see the 14 areas that we do in this feasibility study, and with a strong belief that Comsof is the right tool for this job. We perform this calculation in Rotterdam, 14 locations, and that's mean at the end you will see that we produce a lot of maps for each area. We will go through this in the presentation. Well, there are this is all the areas with the amount of connection points. The next slide, please. Well, with in the whole project, we decide to look into it, and there are 4 starting points for this feasibility study. The due diligence was on the one of the best of important part of this, because this gives us to all the characteristics of each area. The other part was the technical part, in which we go into the infrastructure and the integration of the reality with the calculation. The third point was the business case, as my colleague said. And the fourth point is the scheduling of the engineering, deployment of the network. But in this case, this will be in the near future. So this was not in this at this very moment in the project. Next slide, please. So to do this, yeah, we have some role as engineer bureau during the due diligence, and the due diligence was to bring our knowledge in every place, to get all the information about this, and to maximize the use of those information in the analysis that we will perform for each area. And also, it was supervised by external consultants. So we work together with private consultants. Next slide, please. Of course, as you can see, there is a big process behind this. The next slide, in which we decide to do a kind of conceptual model at high level of abstraction. And this is what you see here, in which you get not only which are the main issues like data, design, and decision making, but also the data control, the requirement of the design, and the requirement of the scenario that we apply in this process. Click going on, please. So then you have the location, you have Comsof, and you have the real situation. This all together give us the dimension of our project. And this is very, I will not go into deep, because here you have more information of more time to explain this, but you can imagine how many things are going in this conceptual model. The next slide, please. To approach this, we set up a project plan with guidance and steps. You can see there, due diligence, the collecting data, the controlling the quality of the data, and so on, until that you got the end of the project. But in some of those steps, you go back to control that what you are doing is correct. So the task and responsibilities was one very important issue in the whole project. Next slide, please. So behind the project, in this case, you have a lot of people. You have a project coordinator, you have a secretary, and all other people that are part of the project, like a project advisor, technical advisor, due diligencer, that are people that was into the field, network design people, GIS people. So a lot of people. This project was more than 25 people involved. So we are here representing these people, and of course we are very proud of all those people, because we just did a part of this, but behind us was a lot of people busy with the whole project. Next slide, please. Well, here you have the duties and the responsibility was in between two big parts, the calculation team and the due diligence. The next slide, please. And then when we come to the Comsof team, in which we are busy and which we are responsible for, we take place 4 people mainly, your technical advisor and GIS, 2 GIS advisors, and 2 energetic advisors, 1 junior and expert is Roland, but also we set up how we will communicate inside of the project and outside of the project to try to afford good communication, because at the end of this, it goes about project management, and communication is one of the very important issues. And I have to add here that we was doing this during the first stage of the pandemic here also in Netherlands, from March until November. So all the communication go through Microsoft Teams. So it was not physical. That give us more stress because it's not the same. But at the end, we got through it, and well, we got the result. The next slide, please. The role and the distribution also was people busy with procurement. We have a project advisor, project auxiliary, project coordinator, manager, technical advisor. It was someone. It was busy with the whole getting the information, and he made the final report. We have an editor and the secretary, of course. Next slide, please. So at the end, with all those work through all those months, we was able to come to the deliver. So the result of our project, and in this place, in this view, you see one of those 14 areas. Next slide, please. So here for this area, you see mainly the result that comes out from Comsof, as I say, a screenshot. But from this screenshot, next slide, please. We produce next one. We produce for all those areas 3 maps for each area. So sometimes more than this, because we have to calculate the areas 2 or more times to try to match the reality and also the scenarios. But at the end, we using also the GIS and also doing commitment inside of the team what we will present. We was able to present and to produce all those maps in which you are at this very moment account of it. So in this case, we you can see all the connection, the transport pipes. The next slide, please. No, you jump. And here, this is also here. You have everything together: the transport pipes, the connection pipe, and the distribution pipe, and also we represent here the demand point. Yes, with the heating consumption. This information was also in our report, with also the report, the result of Comsof, and that is also the return of investment and also the technical reports. And this made the whole project becomes to the body of the whole project as the document. What I want to add at this point is that the whole project was very tough, was difficult, because you have to talk with a lot of people. You have to talk, and you gather a lot of information. Some of the information is not quite good, or not much with the reality. That's why I say that management of the project is very important issue. Communication is a very important issue, and also communication at most is also an issue in which we was going through. Be open mind, review what you are doing, and communicate each other inside and outside with the company that was helping to us, was very important issue, and they give us a good point, and now the result is now clear that Comsof was the right tool, and that with all those composition of the project with the coordinator was also a good person and an open mind. So we went through this project in more than 7 months, and we got the expected result. And now, well, we are waiting to go ahead in the next phase, and that is the phase of engineering. Well, this is next slide, and I think this is the last one. And if you have some question, please. Thank you for your attend to our presentation.
Thank you very much, Freire. Thank you very much, Roland.